How to make gears. I'm working with SketchUp, but it does work with any CAD program as long as you have access to involute gear extension. For SketchUp, you have the extension for gear tree in the description section of the video. To locate gear tree in SketchUp, you go in extension on the top, gear tools, and you can select involute gear. That's what we're gonna work on. From your CAD file, you will find the dead center of the two axes you need the gears for. So you can see right here I have two lines going up. I will measure that size. You can't see my mouse, don't know why, but in the lower right corner you're gonna have 29/16 millimeter. It's kind of huge. It's the way I work with files. I do everything times 100. It's just easier to work with smaller parts. Then you go in your extension, gear tool, involute gear. This is gonna be the 29/16. It's gonna be your pitch radius. It's gonna be the maximum distance in between those two axes. You will then try a different amount of toots to have something that look like a gear. It's just the first step. You will fix that later. For this test, I'm gonna go with 80 toots. Then I'm gonna give some height to my part so I can actually test it in my slicer. That's really important step in 3D printing because you want to make sure that you can actually print those toots. So we're gonna save it, open it in my slicer. You see I have scaled it at 1% just so it fit in my printing bed. Then when you proceed to print, you can see your outside layers. You want at least 2 layers in the teeth. I have 3, it's pretty good. Or at least the minimum, you want some filling in those teeth. If those teeth are empty and only one outside layer, you're gonna have a problem. Now you have proper teeth size. You will take that amount, so we're at 80 teeth for 29/16. You will divide 29/16 by 80. It gives you 36.45. It is not good. You want a round number. So for me it's pretty easy, I already know it. It's 81. You can go up and down until you reach a round number. So 81 give me 36, which is a perfect number. So let's recap. For 29/16 millimeter of pitch radius, you can now have 81 teeth that will be the proper size to be printed and can be divided in between your gears. For that example, I will do a 2:1 ratio, just so you can see the two different numbers. So for my gear 8, I'm going to take 29/16. I'm going to divide it by 3 because you have a 2:1. So my gear 8 is going to be 972 millimeter. My gear B is going to be 1944. This is where the 36 enter in function. You're going to divide 972 by 36, gonna give you the amount of toots for that gear. We have 27 on gear A and 54 on gear B. You can check for reference. You can draw a line for the full size of your pitch radius, then center both your gears on it, and that will confirm if you have the right size, if you did your division well. You're gonna have functional flat gears. You can give them a height and use them as is. Now we're gonna explain how to do angles in the teeth, functional angles, and also herringbone gears. But first I will show you an awesome tool called geargenerator.com. The link is below there in the video. That tool, you can check your gear ratios. So you set your first gear, set your second gear. On the top left, it's gonna give you your ratio. You can try different, you can stack them. It is an awesome tool for gears. Okay, back to our set. We're gonna start with giving them an angle. For it to work, you have to do it by step. If you do it in the full height at once, you're gonna have a narrow center, it won't be working. So we're gonna work with 2mm step on here. So you inflate it, take the top, rotate your first gear with the angle you want. For an obscure reason, you can't just give 5-degree angle to all your gears. It does not work. I'm not good enough in math to actually explain why. It just doesn't. So here's how I do it. Inflate it, 200mm, well, 2mm. Select a point, give him 5-degree angle. That's what we're gonna work with here. So now you have your first level, go up another 200mm and another 5-degree angle. You have your gear A. Now the gear B is a little bit more complex. To get that angle ratio, I tried different math, it wouldn't work, I'm not that good. So what I do is I go back to the first gear, I draw a line from the top of a section to the bottom of the same section, then I measure in between that line and the tip of the tooth. That will give me 91mm. That 91mm, I go on my gear B. I gave her a 2mm, same height as the gear A. I'm gonna draw my lines. So from the bottom of the section to the top, 91mm and up. Then I rotate. So take my top plate, top face, I rotate it, and I can read in the bottom right 2.6 degree. That's a big thing. It's an average because you do it with the mouse, so you have to type it with your keyboard. If you don't do that, it won't work. So now that you have that section, you're gonna realize it is in the wrong way for the other gear. So just take your top face, remove 2.6, you're getting back to 0, then do minus 2.6. It's gonna give you the right rotation for the first gear. Now that you have your angle and your height, you pop it up another 2mm, another 2.6, the same direction, and we can see here our gears are a perfect match. From there, go back to your gear A. If you want to do a herringbone, you lift and you're gonna rotate in the opposite direction. So you're gonna do 2 section, or it depends on the size you want to reach. For this one, I was reaching 8mm total, so I did 2 section on the one side. I'm gonna do 2 section on the other side. I'm gonna get a perfect herringbone, and I know the gear fits with their axes. They're not too far, they're not too close, and there it is. It seems complicated. Once you get used to it, it is really easy. Just remember, take your 2 numbers from your 2 axes. That's your pitch radius. Divide it between the gears you need. If you have a floating gear in the middle, I prefer to do it in 2 different maps. So you do gear A to the middle gear, then the middle gear to gear B. But yeah, you divide it. You get your gear ratio from geargenerator.com. You can get the gear ratios you want, and there it is.